We open over the I-55 and Route 7 interchange with the campus's private drive in view. Turning off Route 7 onto that private drive by the water quality plant and the combined cycle power block, the plan reads quickly: a compact, gridded campus that installs faster, maintains easier, and scales predictably. Unlike most gridded campuses, we keep utilities in grass-first corridors, using selective stone where wheel loads or code require and paving the primary drives and yard aprons as standard. The result is shorter trenching, cooler surfaces, easier inspection, and lower lifecycle maintenance, with less overall pavement. If an end user prefers a harder look in lieu of grass, continuous stone or hardscape behind the curb remains an option without changing the backbone. Rolling in from Route 7, the firewater assets anchor resiliency. Storage and pumps are placed for clear access and short runs to the backbone. Adjacent, the on-site water quality plant polishes industrial and process water for reuse, reducing makeup demand and chemical handling while stabilizing operations. A reserved expansion pad allows added polishing and blowdown recovery as loads grow. Rising above the corridor, the elevated tank provides shared pressure and storage for domestic, process, and fire. One coordinated system that supports phased growth without replumbing the campus. Below the corridors, 3 Columbia Gulf transmission lines traverse the property. They feed a looped header serving the reciprocating engine yards, and the combined cycle plant's measurement and regulation station is dual-fed from opposite ends. Routing prioritizes the grass-first corridors, safer to access, simpler to maintain, and less paving work overall, while paved access lanes and designated bucket truck turnouts keep service reliable. The combined cycle power block sits on high ground at the center of the platform. While that plant builds, reciprocating engine modules provide roughly 100 megawatts per building in an N+1 configuration, purpose-built backup that keeps density and uptime front and center. Power is delivered behind the meter on private wire AB. No utility export is assumed. From the substations, A and B feeders stay off pavement in the grass-stone first corridors with switchable nodes at key points for safe isolation and straightforward maintenance. Just ahead, the cooling backbone ties in. Centralized low-water cooling loops, chilled water supply, and return to the halls. In secondary, chiller heat is reused where it helps. Chiller halls sit opposite the residential edge and face inward to the campus. Fans are specified for low sound, and the corridors preserve natural setbacks. Running primarily dry hybrid reduces chemicals and visible plumes and trims cooling energy by about 10% versus conventional evaporative plants, on the order of approximately 180 gigawatt hours per year at campus scale, worth approximately $12.6 million per year at $70 per megawatt hour, and materially more at typical industrial tariffs. The data center grid reads simple by design. Each hall has 4 standardized fiber entries on the short end, with dual, diverse laterals running those same corridors to regional POP/IXP points. Standardized splice vaults keep work repeatable, reduce change order risk, and preserve low latency as phases add. Tracking along the southern edge, stormwater and grading come into frame. We follow existing drainage patterns and size detention to release below existing flows toward the neighborhood. Bench-ready grading keeps most utility work inside the corridors. Grass-dominant routes reduce heat island and improve infiltration relative to continuous pavement. And, because corridors remain primarily grass, we use much less paved acreage than a typical all-pavement grid, while selective stone and planned pavement handle heavy vehicles and drainage transitions. Domestic sanitary is straightforward. It flows by gravity to the park's American Way sewer, with only a short local force main where needed. We swing out toward American Way to show connectivity, then flip and ride the creek line back across the site. 3 isolated support buildings sit beyond the water, warehouse and maintenance forming a built buffer, with the quiet side of the substations presenting to the edge. Recip yards face inward by design, and stacks are centralized on the site's highest ground and oriented inward, improving dispersion, reducing line of sight to the perimeter, and keeping maintenance activity in the core. As we return over the power block, chiller halls, water quality plant, elevated storage, and the Route 7 entrance, the numbers come together. The low water plant and reuse strategy reduces cooling energy by approximately 10% on a full campus basis, and with the reserved expansion pad built out for additional polishing and blowdown recovery, potable makeup can drop approximately 30 to 60%, roughly approximately 780 million gallons per year at campus scale, while further trimming cooling energy subject to final selections and duty cycle. This is Grenada. Standardized kits, grass-routed loops, selective stone and planned pavement where it's needed, and a low-water heat-assist central plant engineered for faster installs, cleaner operations, and power density few sites can match, one of the most power-dense, execution-ready AI campuses in the United States.